In this video, I will show you how to evaluate expressions like the sine of a minus b, cosine of a plus b, sine of 2a, tangent of 2a, and even how to find the quadrant of 2a, given a little bit of information. Basically, given the quadrant of a and the quadrant of b, which is what this really is, and one trig value. So let's get started. The first thing we're going to need to do is draw ourselves a couple of triangle diagrams, one for angle A and one for angle B. So angle A is between pi and 3 pi over 2. They are describing the third quadrant. So we need to draw a little diagram of the third quadrant like this. Alright, so here's our angle in the third quadrant, and I will make a vertical line to the x-axis, making a right triangle. Now, so cosine of angle A is negative 8 over 17. I know that cosine is the x value over the radius. So the radius is 17, which is always positive. That means this negative sign really belongs to the 8. So my x value is negative 8, so I'm going to put my negative 8 right here. I'm going to do the Pythagorean theorem to find the y value, but now this is really important. The y value, whatever it is negative because this is down below the x-axis, so my y value will be negative. So let's go ahead and do a quick Pythagorean theorem. So x squared plus y squared is equal to the hypotenuse squared. So that'll be 64 plus y squared is equal to 289. Subtracting 64 from both sides, y squared is 225. Therefore y is equal to positive or negative 15, but as I said, because this is down, it has to be negative 15. Now, I cannot overemphasize this. You have to be careful to make this a negative 15, not a positive 15, because if you do that wrong, that is going to affect your answer for all 6 of these questions. So if this were a test, you wouldn't just get 1 question wrong, you would get 6 questions wrong, and that would just devastate your grade. So this has to be right. It's simple, but you have to stop and think about it to make sure you don't make a mistake. Anyway, this is angle A, so let me just clearly label this as being angle A. Now let's make a similar diagram for angle B, which is also in the third quadrant. So we will just make another diagram that looks almost the same. Okay, so for angle B, we're given cosine. Well, okay, that's the same thing we were given last time. So again, cosine is x over r. Again, I will look at this as being a negative 3. So I've got my negative 3 here, and my 5 is here. If I were to do the Pythagorean theorem, I would come up with 4. And again, this must be a negative 4. Do not just put positive 4. So this is my diagram for angle B. Alright, so now we're just going to use our sum and difference formulas to set up values that, expressions that we can evaluate. So the sine of a minus b. So the way the formula goes is it's going to be sine, cosine, cosine, sine. So we're going to be doing sine A cosine B minus cosine B sine A. That's all we're going to be doing. Okay, so looking at the first diagram for angle A, the sine is y over r. So that's going to be negative 15 over 17. The cosine of b, so I need to look at this one. That's x over r, so that's negative 3 over 5. Minus cosine of b. No, that's not right. Why didn't you guys say anything when you saw me write this wrong? Write this wrong like I'm a soldier of justice. It should be the order of the letters, the angles doesn't change. I should have written cosine A, sine B. That's better. Sine, cosine, cosine, sine, but the A, B stays the same. Anyway, so cosine A. So negative 8 over 17. And then sine B. So that's negative 4 over 5. So that is how you do that. A negative times a negative is a positive, so this is going to make 45 over, let's see, what's 17 times 5? 17 times 5 is 85. Okay, now I have a minus, I have 3 minuses, so I know the net result is it's going to still be minus. So I'm going to have minus, and 8 times 4 is 32. So that's going to be 32 over 85. Okay. Alright, so I've got 13 over 85 for my final answer right there. Okay, let's do the same thing for the cosine of a plus b. Now looking at the formula, cosine will go cosine, cosine minus sine, sine. So it should be like this. Cosine A, cosine B minus sine A, sine B. Okay, so the cosine of A is negative 8 over 17. The cosine of B is negative 3 over 5 minus sine of A is negative 15 over 17. Sine of B is negative 4 over 5. So it's just a matter of evaluating this. Negative times negative is a positive, so this will make positive 24 over 85. Now I see 3 negatives here. A negative times negative is a positive, so that'll leave this as subtraction. And 4 times 15 is 60. So I have 60 over 85. Okay, so the final answer is negative 36 over 85. Alright, let's do that again for the sine of 2a. So this will involve another version of the sum and difference formula. It's not really brand new, but the sine of 2a will equal 2 sine a cosine a. Okay, so this is going to equal 2 sine a cosine a. We're just going to use that double angle formula. So for this problem, we're only looking at angle A. So what is the sine of A? So looking back at that diagram again, that was negative 15 over 17. Okay, what about the cosine of A? That was negative 8 over 17. Okay, look at this as being 2 over 1. Just multiply this all together and see what you get. 240 over 289. A negative times a negative is positive. Okay, I just did 2 times 15 times 8. That's 240. Okay, that's it for that. What about cosine of 2a? Well, the formula there, well, we have a choice. We could use any of these 3 versions of the formula. I'm just going to use the first one, cosine squared a minus sine squared a. Okay, so I'm going to do cosine squared a minus sine squared a. So that means I'm going to do the cosine squared minus the sine squared. Okay, and we can see this from the previous problem over here that cosine of a was negative 8 over 17. And the sine of a was negative 15 over 17. So we have this. If you square something, it turns positive, so I don't really need to worry about that negative sign. So this will be 64 over 289. And this will be 225 over 289. So it's just a matter of 64 minus 225. Okay, so this is the final answer for D. Okay, what's next? E, tangent of 2a. Now there is a double angle formula for the tangent of 2a, and I could use this formula to find the answer. However, we also know that tangent is sine over cosine, and we just found the sine and the cosine. So it would be easier if we use those values. So I'm going to evaluate this by doing sine 2a over cosine 2a instead of using the tangent formula. So sine of 2a was 240 over 289. And the cosine was 161, well, negative 161 over 289. So negative 161 over 289. Now, as a shortcut, I could multiply by the reciprocal, but as a shortcut, see how these denominators are both the same? They're going to definitely end up canceling out. So I'm just going to be left with these numerators. So that's why the final answer for tangent will be 240 over negative 161. Okay, so that is the final answer for E. Now, what about the quadrant of 2a? Well, the quadrant is going to depend on whether the sine, cosine, and tangent were positive or negative. So looking back at our previous problems, and we really could answer the question just based on the sine and the cosine. Notice that the sine of 2a was a positive number. Okay, positive 240 over 289, but all I really need is the fact that it is positive. Notice that the cosine of 2a was a negative number. Okay, now also I have the tangent right here. Alright, the tangent of 2a also turned out to be a negative number. But I will already know the quadrant before I get to the tangent. Okay, so we just look at the unit circle and ask ourselves, where is sine and cosine and tangent? Where are they positive and where are they negative? So, where is the sine function positive? Well, the sine function is positive above the x-axis. The sine function is positive here and here. Where is the cosine function? Negative. Well, cosine, that's x value, so cosine is negative to the left. So the cosine will be negative in this quadrant and this quadrant. So already I can see that the only quadrant that satisfies both of those is quadrant number 2. So that is going to be the answer, and I can already say that the quadrant of 2a must be quadrant 2. But just to verify, let's talk about the tangent of 2a. Okay, where is tangent negative? Well, tangent is negative in this quadrant and this quadrant. And again, we see that the second quadrant satisfies all three of these descriptions.